Okay, so now we're on number 7 and number 8. Now this question's asking, they give you this linear system, and they're saying they also give you an inverse. So if I was to call this A, this would be the A also, and this is the A, this is A inverse, right? So they give you A inverse. Now, this is a tricky question. They're not asking you to actually solve anything. This is all about the concept behind what a linear system actually is, and how to actually find the solutions of a linear system. Um, Basically, the background is when we had something back, long time ago in a land far, far away. We had something like that was 3x equals to 6, and we would divide both sides by 3, and we would get x equals 2, right? And this would give us the solutions. But when we're working with matrices, we can't divide out things, but we can take the inverse of things. So if we say this is ax plus c, ax equals c, instead of dividing out a, we can multiply both sides by a inverse of ax is equal to c times a inverse. And this turns into an identity. And the solutions to the system is just c times the a inverse. Now, what does this tell us? If this is our c, if this is our c, and this is our a inverse, then voila, man, that's it. So the answer is B. Next question. Moving on to 8. This is a very nice question as well. Really simple. You should be able to get it in a fair bit amount of time. It has to go with the above example that I just kind of went through. And it's just a couple of properties that you would have to kind of memorize. They're in the textbook. So make sure to go over those. First of all, what I want to do is we know that A times the A inverse is equal to an identity. So I want to put an identity on this side. So how will I do that? Well, I'll just multiply by A t minus 2I on both sides. So we get A transpose minus 2I inverse. And I'm going to call this matrix here B. Just for the sake of space, keeps things clean. So we get something that's called B times A transpose minus 2I. Okay, this is gonna be an identity is equal to B times A transpose minus 2I. Now, I'm gonna factor out the AB times A transpose minus 2IB, and I'm gonna bring this on this side, which is just I plus 2B. I can get rid of this I, just because multiplying this with an identity with a matrix just give us the matrix itself. So it's going to be plus 2b, right, is equal to b times A transpose. Now, just like we did in the above example, I'm going to multiply both sides by the inverse of b. So I plus 2b times the inverse of b is equal to A transpose. Now just take the transpose of both sides, and we should have the formula that is required to find A. Now to actually do all that work. Okay, so I'll do this step by step. We know B is equal to 3, 1, 2, 2. We know that the inverse of B is actually just, what is it, negative 1 over negative 2. This turns negative. These switch spots, and we have 1 over AD minus BC. So 6 minus 4, minus 2, sorry, which is equal to B inverse is equal, right, to, this is equal to 1 over 4, right, this is equal to 1 over 4. Now, 1 over 4, so we have 1/2 here, minus 1 over 4, minus a half, 3 over 4. That is B inverse. Okay, what's an I? I is just equal to, 1, 0, 0, 1. Now, let's actually do this now. 2 times B. You can use, this 2 times B is just, 6, 2, 4, 4, right? Plus 1, 0, 0, 1. All that, right? All that stuff times B inverse, and take the transpose of that. So if you continue on, we get something like 7, so right? 7, 2, 4, 4, 4, 5. And then we multiply that by the inverse, and the inverse is just 1/2, negative 1 over 4, negative 1 over 2, 3 over 4. We multiply that by the inverse. What do we get? Simplifying it, you can use multiplying. What I do when I multiply, the easiest way I remember, is basically I take this row and I just kind of flip it around and multiply it by this row. That's what I do to multiply matrices. Now, what does that equal? Well, what do we have here? We have 5 over 2, negative 1/2, negative 1 over 4, actually, sorry, negative 1 over 4, negative 1 over 2, 11 over 4, right? But are we done? No, we're not done because we didn't take the transpose. So after we take the transpose, right, we have to take the transpose of all this, and that equals A. And then taking transpose is not too bad. You just flip these rows and columns, right? So you get 5 over 2, negative 1/2, negative 1 over 4, and 11 over 4. So the diagonal always stays the same, and this equals A. Going back to our possibilities, we know that our answer is B. Stay tuned for the next video.